In addition to using the environment variables that are provided for us, we can also use variables that are just internal to the scripts. So right now I'm following the examples in Chapter 11 on pages 276 and following in the text. And I went ahead and just entered the files, since I'm such a slow typist anyway, so that I could just show them to you. So here is the file called test3. And here we create some new variables. So we create a variables called days, and we assign it the value 10, a numeric value. Here we're assigning a string value. Remember, a string is just a set of characters together, right? So the variable guessed then refers to that. So if I want to read those values back and substitute them somewhere, then just like using the environment variables, I'll put the $ before them. So in this case, I echo whatever the value of guessed is, it should expand here, checked in, and then whatever the value days is right here. And then I change days to a different value and guessed to a different value. One thing I do want to point out that's very crucial, there are no spaces between the variable here and the equal sign and the value that's on the right hand side. And that's actually very important, because in general, when there's a space, that's interpreted differently by the command shell, and it's trying to look for commands and parameters when you do that. So be sure that the equal sign is not surrounded by any white space, and it'll work just fine for you. So let's take a look at that one and see what that does. And there you go. So you see that each of those variables then was expanded in the output. Let's take a look at another example, which is test 4, and learn a little bit more here. So here we're going to assign a variable to a different variable. So I have a variable called val1 right here, and the value 10 is assigned to it. And then I have another variable called val2, and we'll assign it whatever value is in val1. $ means the value of whatever that variable is, right? So when we do that, we would expect that this will expand to the value 10. That's the expectation. Now, one thing I'll point out is if when you're looking for the value of some variable, you're wanting to expand it, replace it with its value, if you leave out the $, that's not what you get at all. I'll show you. I've got a second one that says if we forget the $, then the resulting value is. Let's see what we get. Okay, let's run test 4 there. So using the $, the resulting value is 10. If we forget the $, in the assignment operation, the resulting value is, look, val1. So going back to that file, you see it just assigned it as if this was just a text string. It assigned that value to val2. If you have the $, it knows to assign it the value of whatever that variable was. So $, means read the value from the variable called this and put it here instead. Okay, does that make sense? Hopefully so. Now let's work on another one, and we'll call this one test 5, and you know how they all start, right? Don't forget this /bin/bash, okay, which says this is going to be a bash shell. And let's take one of the commands that we used before. We'll use the date command, and what I can do is say val equals. Now then, I'm going to use a special character on the keyboard. This is on the same key where the tilde is. It's in the upper left, underneath your escape key, and above the tab key on a standard keyboard. It's to the left of the 1 in the same row. This is called the backtick. Notice this is not the same as the single quote. The single quote key, which is next to the enter key, looks like that. You see, totally different symbols. So if we use the backtick key and we use it at the end of the command as well, what we're saying is val is going to be set or assigned the value of this command. Please run this command separately in a subshell and take the value that it generates, whatever output it generates, and set val equal to that. And so now we can say right here, how about echo the value is, and we'll do that. That look reasonable? Okay, so let's save that file and exit. And of course, we know that we need to give execute permissions to test 5, right? And so now we'll run test 5. And so the value is, and you see it's followed by whatever the date command would have generated. If I just type the date command here, that's exactly what I get, okay? So you're able to execute a command, capture its output, whatever it is, and then make use of that later on in your script at any time that you want to. There's another way to do this. There's another syntax for it. And let's just go back into the file. I'll show you what the syntax is. And that is, instead of using the this backtick symbol here, you can use a $ and an open parenthesis and then a close parenthesis, like so. So this might look a little more like assigning one variable's value to another. The way I would read this is assign val the value of the variable produced when we run the date command. Okay, so that will do the exact same thing. And I can show you that, we could perhaps use a different command. How about, ls-l. Okay, and we'll write that, exit, and let's run test 5 now. And you see the value is, and then you get all the output that you would have gotten from ls-l, right? Okay. So how would you make use of this in practice? Well, you could do something like, val could become, how about the file name? We could say that the file name is is equal to file, and then follow it with, let's go back to the date. So we'll say the file name where we will store today's log is, and we changed that name, right? So let's change that to file name. And let's run test 5. The file name where we'll store today's log is, and then of course we've got the word file in front of each one, and then we probably should have had some other characters, but anyway. Now we've got a unique file name. So let's talk about redirecting output a little bit. The output of any command that would generally occur in the console in front of you here on the screen can also be sent somewhere else, like to a file or something like that. And so a good example of that might be if I wanted to, let's type something like this that you're well familiar with. I get something like that. If I want that to go to a file instead of going to the screen in front of me, I use this symbol right here. It looks kind of like an arrow. So basically we're saying redirect the output of this thing to something else. And let's call this file test 6, if you will. And now notice I don't get any output on the screen when I do that. And if I cat test 6, you notice that I have the output from the command there. I could do some other things too. ls-l, that will generate some output. Let's send that to the file test6, and now if I cat test6, you see that it contains that. Notice that the /home/Perry that was there before is gone. If I want to concatenate multiple things to the file without destroying what's already in there, then I would use a slightly different symbol. It'll look something like this. I can say echo user, and we'll send that to test 6, and then maybe we'll echo the UID, say that to test 6, and now when I do that, you see that those appear here at the bottom along with. So it just tacks the output of those commands onto the end. So this will create a file if it does not exist, and it will send all the output to that file. If the file does exist, it will delete whatever exists in that file and replace it with whatever generated by the command to the left. This one, likewise, this redirection will create the file if it does not exist, and then send this to the end of that file. If the file already exists, then it will tack whatever the output of the command to the left is on to the end of that file without overwriting whatever was already there. This redirection also works for input, not just output. And so we'll use for this, let's take a look at the word count command, WC, for new line word and byte counts for each new file. So new line, essentially how many lines are in the file, how many words are in the file, and how many bytes are in the file is the way that works. So there are of course some options, but you can say WC space and then a file name, and that'll give you what you want. So if I said word count for test 6, it tells me that test 6 has 10 lines, 67 words, and 350 bytes. And you remember test 6 has all of this. You can see the 10 lines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There they are. Okay, and you could count words if you like and see what it means by a word. This would be a word. This also would be a word. I'm not sure if it counts that as 2 words with that in between. Probably not. I think it's probably white space by default. I'm sure you can set it. Read the man page if you're interested. So the example given in the book is rather than specifying the file, we can actually redirect input to the word count straight from the command line there. Now, why would I do that instead of just saying this at this point? Don't worry about it. We'll get to good uses for redirection. Just want to introduce it. So, which symbol do you use? How do you memorize these? Well, if you're trying to redirect output, first comes the command, and then comes the place where you want the output to go, and there's an arrow kind of between them. Just imagine that as being, rather than a greater than sign, imagine that being an arrow. So the arrow points to where I want the output from this command to go. Likewise, when we're redirecting input, we have the command first, and then the arrow, and notice the arrow is going into the command, so that would be input to the command. So you can think of it that way. The command always goes first, and then the symbol goes in the direction that information is flowing, and that's probably the most crucial thing to know. Do check out on the top of page 281, there's also a symbol like this. That is used for redirection, and you can kind of see what that's about. I'm sure we'll have occasion to use it at some point through the course, and I'll try to explain it as we get there, or at least bring it back to your remembrance, but you'll want to check that out in the text. So the next one to know about is piping, and there's a good explanation of this in the text, but I'll give you a couple of examples. What is a pipe? Well, the symbol that you use is this key that's right above the enter key. It has a backslash on it, but then if you hold down the shift key, it has this vertical bar right here, and we call that a pipe. So what good is a pipe? Well, a pipe allows you to pass the input from, or pass the output from one command into the input of another command. This is going to be really crucial as we start to build up scripts, because we'll be able to run a command, get the output from that, maybe send it to another command in order to process it in some way, maybe sort it or strip some information out or whatever, find the stuff that we're interested in, and then maybe we even send that to another command. So we can build up kind of sophisticated things. You can do this on the command line. You can also do it in scripts. But a perfect example would be using this word count. If I were to say, WC-L test 6, that's just going to show me the number of lines. So that's the first one there. Notice 10 lines in that file. How can I use this? What if I want to know how many files are in this directory? I could say ls-l. This would give me the total number of files and directories, right? I'm going to get 1 per line, and then I can pipe that into WC-L. And what do I get? I get 8. Now I know that I don't quite have 8. I only have 7, right? Here they are: 1, 2, 3, 4, 5, 6, and 7. That's the output of an ls command. But I also get this additional one, so it's going to be high by 1. But the point is, I can get some idea. I can do that just by typing ls-l, right? Well, what if it's several pages of output? I just want to get a quick count. That'd be pretty reasonable. I could use it in this way too. How about ps AUX? We'll pipe that into WC-L. 166. So I've got 166 processes running on my machine. Actually, it's probably 165 because I think that there's a header there as well. I can see that PSAUX. If I scroll to the top here, let's see, there's a header up there, isn't there? Yeah, see there's this header. So I have to subtract one from it, and in the next section we'll learn how to do expressions and some arithmetic. So sometimes we need to perform mathematical operations within the shell, either at the command line or more commonly within shell scripts. This is a rudimentary capability of any kind of scripting language, is the ability to perform mathematical calculations. We would not expect that we would use this to do extremely complex stuff, but we might use it for a variety of purposes. For example, if we needed to format a table of output and we needed to figure out how many columns and how many rows we have based on how many items we want to lay out, that sort of a thing, we might perform some rudimentary mathematical calculations. So this will be something that we'll need. But there are several ways to do this within the bash shell. 3 in particular that we'll take a look at. The first way is very legacy. It's been around for a long time, way back with the Bourne shell. So we're talking 30, 40 years old. And this is the EXPR command. And very simply, it works just like anything else in the shell. We type a command and then we send it parameters. Our parameters could be something like this, and what this will return is the value of the expression that's to the right of the command. But basically think of it this way: the EXPR command is receiving 3 parameters and then it's interpreting those, a 2 and then the plus symbol and then the 5, and it returns the answer 7 just as you would expect. And of course it can do much more than just plus, it can do -2, and so there you go. It's a negative. Now the thing is, there are some symbols that we would use in mathematical expressions that have a different meaning in the shell. For example, asterisk is the wildcard character that we've seen before when we specified files. And so if we were to just try to send that, the shell's going to interpret that asterisk as meaning something else. It's going to expand that actually to a list of files here. And so we're going to get a syntax error there because the expression command doesn't know what to make of that. So this becomes kludgy and clunky really, really fast because I'm going to have to escape that asterisk in order to send it by using the backslash. And that's what we'll call that. We call that escaping the character. And what that means basically is we're putting a symbol there saying, no, I really want you to not interpret what's coming next to this asterisk, but I want you to just send an asterisk to EXPR, and don't worry, EXPR will know what to do with that. And indeed it does, and it gives us the correct answer. And of course, we can also do division, like so. Now, this is rather interesting. It points out a problem already with the EXPR command. Notice the answer to the other 3 are correct, that is plus, minus, and times, but divided has an interesting behavior. You know that 2 divided by 5 is not exactly 0, is it? Notice that it rounds down to 0. It will always do this. It will always round down. So if I, for example, say EXPR 10 divided by 2, you'll get 5 as you would expect. But if I say 11 divided by 2, what do you expect it to be? That's 5.5, right? It's 5.5, but you'll see that you get 5. The EXPR command is only capable of doing integer arithmetic. Okay, so it only deals in whole numbers, and so it will round down when we do divisions. So we will find a method to handle numbers that are not integers. What are integers? Those are whole numbers, right? So like 1, 2, 3, 4, your counting numbers, and -1, -2, and 0. But it does not include numbers like 3.14 or 6.6 or 1.5, numbers that have a fractional part, something to the right of the decimal point. So EXPR cannot handle those. So when we need those, we'll have to use a different method, and we'll see what that different method is here in a few minutes. One thing I do want to point out about the EXPR command, remember it's receiving each of these parameters as separate parameters. So if I do this, then what I get back is it says 2 plus 5. What is it? What's the problem here? Why didn't I get 7? Because I didn't have spaces actually between each of the parameters there, and so it just gives me back whatever I said. So if I said, if I said expression, XPR howdy, it says, okay, howdy, just give you back what you gave me. I don't know what to make of this, so I'll just echo it back. Okay, so there is that. So what do you need to do then in the prior example? You need to go in and insert your spaces. Okay, so that's the EXPR command. Now, when we're doing this in a shell script, we can certainly do the exact same thing, EXPR, and we'll use the same kind of command substitution that we did before. So let me show you an example of that, and I've already entered that in now, overwritten our test 6 from before, and here you can see the application of this. So we've got a shell script here. We set var1 equal to some value, var2 equal to some value. Why are we doing this? Well, imagine as we get a little more sophisticated with our shell scripts, we might be reading in some values from a user for something. Could be a file name or something like that. It could be coming from the command line when the script is run. We'll be able to access those things and then do things based on them. But in this case, we're just setting them equal to something. So let's learn to do these simple things first, and we'll get more complex as we go. So I've got var1 and var2 set as certain local variables inside my shell script. var3 then is going to be, and remember these symbols right here. We have the $, open paren and close paren. This is command substitution. What we're saying is whatever command is inside those things, execute that, and whatever its output is, let that be the value, a temporary variable, and I'll set var3 equal to that. Okay, I will assign var3 the value of whatever that command basically returns. And so what is the command? Well, here's our EXPR, $var2 divided by $var1, and then echo the result. And so I can go ahead and run that. I've already, I think that test 6 is already, it's already executable. So I can just type test 6 right here, and you see that the result is 2. So that is var2 divided by var1, 20 divided by 10 is indeed 2. And so var3 is set equal to the value of 2, and then the result is, and so now it is output for us. So that's how we make use of those. Now, as I said, this capability that we have to use the EXPR command is legacy. It comes from a long way back. There's something slightly more modern that is provided in the bash shell, which makes things a little bit easier. That is, we don't have to type a command like EXPR to do math in the shell. We can also use this syntax that, well, if you're following the text, it's page 287 in the text. We can use the square brackets with a $sign to perform some math. So, for example, I can set var1. Now then, of course, I'm doing this just at the shell, right? But to follow the example in the text, 1 plus 5, still need the spaces in there. Okay, notice it's square bracket, so it's $sign, open square bracket, then the expression, and then close square bracket at the end. So there it is, and we can take a look at what we have there, and we have the answer. So that's an easy way to put these things together. And so we'll say this one, var2 equals, remember, no spaces between a variable and its assignment ever, right? But now we can make use of that var1, always spaces between the parameters for an expression like this, right? So I know it's kind of hard to remember those differences, but if it doesn't work, think about the spaces real quick, okay? And let's just echo var2, and there you go, 12. So just as expected. We can also do that in a shell script. So let's look at test 7. I think that's exactly what's in the text. I just kind of typed it in real quick while I was on the break here. So you see what this one is doing. var1, var2, and var3 are set to various values. var4 is set to the calculation of var1 times quantity var2 minus var3. The parentheses will express an order of operation just like in math. Notice again the use of spaces around the operators there and the lack of spaces around the assignment operator. That's very important. The final result is, and we indicate var4. So test 7, I'm just looking up here to make sure that test 7 is indeed executable. It is. So I run test 7. The final result is 500, and you can verify that at your leisure. So now let's take a look at the third option, which is going to be a little better solution in some ways, although one that might sometimes be a little more cumbersome than we need. But if we need floating point numbers, that is, we need numbers with fractional components, we need to have something to the right of the decimal place, like the number 5.5 or 3.14159 or whatever. We need something after the decimal point, non-whole numbers. Then we'll need another solution. And for that, we'll use the BC command, which stands for bash calculator. So first we'll operate the bash calculator here at the command line, and then we'll see how the bash calculator works in scripts, because we can use it in scripts to do any kind of calculation that we need and gain access to those real numbers, not just integers. So first thing we want to do, type BC for bash calculator. You can do this anytime from the bash shell prompt. You get this message up here. I'll show you how to disable that in just a second. In fact, let me just do this. Example as we have it in the text. I can enter 12 times 5.4. Just for lack of creativity, I'll use exactly what's in the text. Get the answer 64.8. How about this one? 3.156 times, and we'll say 3 plus 5. And we get this answer right here. And we'll go ahead and quit. There is another mode if you man BC. You can learn all about this, and there's a variety of different things, but the one we'll take a look at is this one right here, the -q quiet, do not print the normal, new BC welcome. That sounds good because we don't need all that. So you can say BC-Q and see you don't get those lines. You've just got the blinking cursor there. And we can add something. How about 3.44 divided by 5? That ought to give us some interesting number, and it gives us 0. Now, why does it give us 0? The issue there is that it's only showing a certain number of decimal places of precision. You can set that. I'll show you how to do it. We say scale equals 4, and now let's do the same thing. You can use the up arrow to get back to it, and there it is. It was rounding down because I wasn't showing the default scale is 0, which says show 0 things to the right of the decimal point. Why is that? I don't know, but you have to remember that so that you can get the kind of output that you want. Type quit to exit, and there it is. Okay, so if I launch BC again, take the third example here, I can make var1. Now notice this is not just a shell variable. This is inside the BC. Okay, so var1 equals 10, and I can look at var1 times 40. Notice I'm not setting anything equal to something. I'm just putting an expression here. It's going to give me the result of that expression. var2 equals var1 divided by 5. What do you expect that to be? That should be 2, right? And you can use this command, print var2. Actually see the value of 2 of var2 right there, and then quit. And so there's lots of stuff on the internet if you want to learn a little more about what things the calculator can do, but that's enough for now. So how do we use these in shell scripts? So basically, take a look at page 290 if you've got it. Look at the very top there. You see the basic format to use this thing. How do you do it? You're going to use command substitution, and we're going to use the pipe to basically send a string with options and then the expressions that we want to, the expression that we want to calculate to BC. And so we use that on the right side of an assignment statement. So we say variable equals, and then it's the $ open paren and then close paren. And inside that, what are we doing? We're taking a string we'll use echo in order to output that string, and we'll send it to BC. So there's the basic format of the thing. So let's go ahead and make one of those. I'll pause the video for a second, go ahead and type it so you're not having to wait for me to type, and then we'll walk through it. Okay, so now I went away for a couple of minutes, made a couple of scripts. Let's take a look at test 9 first. So here's the script. Now I'm going to make use of the same kind of thing, command substitution here, but I'll set it equal to a variable. So I've got this echo right here. Remember, set the scale first. Then the calculation that you want to perform. So here it's pi divided by 4. Okay, so 1/4 pi is whatever. So let's execute that one. And 1/4 pi is so much as that. Now for the other one, I haven't even looked at it yet. So let's haven't even tested it. So let's see if if I wrote it right. I'll show you what I'm trying to do. So I set pi equal to this value. Square root of 2 is going to be, notice the command substitution here. We echo, the scale 8, so 8 decimals to the right of the decimal point. And then call the function square root of 2, which BC has. So let's see if I did that right. And then pi square root of 2 equals, again, command substitution, and now you see I'm using both of these variables here. And then so I echo out the 3 variables. So I'll give you a minute to take a look at that. And let's see what that one does. Test 10. And let's see, so pi is 3.14, etc. Square root of 2 is, about 1.4, etc., etc. And pi times, supposed to say times square root of 2, I mistyped, that's all right, is this much. And so that's about right. So I think that's pretty good. So that gives us the ability to deal with numbers that are not necessarily integers, but rather are floating point numbers. Our last topic for today is exit statuses for scripts and commands. Now, it's very important when we start putting together lots of commands in a script that we're able to determine if an operation is successful or if it fails. And if it fails, sometimes we want to know the reason that it failed. Sometimes we can try an operation, and as you know from typing things to the command line, sometimes you type it wrong, or you don't have permissions, or something else, and so whatever you're trying to accomplish actually doesn't get accomplished. It would be really bad if we're trying to put together a script that is doing a variety of interesting things one after the other. It would be kind of bad if, say, the first operation fails, and we're assuming that it succeeded in order to do the second, and then the third, and then the fourth, and the fifth, and we just keep going as if nothing happened, right? That would be very foolish. So we need to know when things are successful or when they fail. And the way that we know that is usually by the exit status that is returned by the command. Now, by default, if a script terminates and you've not given any kind of exit status, the exit status for that command will be 0. However, we usually want to be pretty explicit about exit statuses, and we haven't done that in any of our scripts yet. But if I were to, right now, echo this special variable, which looks like this, its name is question mark, that is going to be the exit status of the last thing that ran. So in this case, it's test 10. If I do that, I see that its exit status was 0. Now, 0 sounds like nothing at all, right? But 0 is really good. That's actually, think of it this way, nothing went wrong. Okay, so 0 things went wrong. And if you look at table 11.2 on page 293, you'll see what some of the most common errors are that can occur. That is, you have various codes. 1 to 126 means the command can't execute. 127 means command not found. That sort of thing. So, I'll type that, command not found. Let's see what we get. We get code 127. That command was not found. So I can actually check these things in a script, and I can also, of course, go ahead and expressly indicate an exit code in my script. Okay, so let me just go back to our test 10. How would we expressly indicate an exit code? I'll just do it like this, exit 0. And that's going to be good. Now, you're going to find out that as we start building scripts, there will be cases where we'll see that a command could fail. We'll check to see if it failed. If it did, we'll go ahead and exit the script with an appropriate exit code, so that if that script is used as part of another script or even from the command line, there's a failure code that is given, which gives us some kind of useful information. Okay, so from now on, then we'll be using the exit command in order to exit a script gracefully rather than just kind of falling off of the end of it, which is what we've been doing so far. One thing that you want to be aware of as we do this, though, very, very important, is that the exit codes can only go from 0 to 255. If you want to know why that is, basically we have 8 bits or 1 byte that constitute the exit code. So it's an unsigned integer from 0 to 255. If you try to send a number larger than that for the exit, it'll end up wrapping back around or truncating it in some way, so you can get some unpredictable results. You might get some kind of code and you say, what in the world does that mean? But it will end up being a number from 0 to 255, even if you try to send something bigger. So that's generally not something that you want to do, because it's not that easy to figure out what's actually going to be returned. But again, 0 means successful completion. And if you don't have any other idea of what code to send when something fails, you would use code 1 for a general unknown error. So if you fail, you exit with a 1. If you succeed, you exit with a 0. That would be kind of your most basic approach to exit codes in the scripts that you will end up writing. So that'll be it for now, and next week, if you kind of look ahead to Chapter 7, you'll see that we're getting into structured commands. What does that mean? That means that rather than just having a script that runs from top to bottom and executes all the commands in order, we'll be able to determine if we want to execute a certain command or possibly do something else instead based on certain conditions. And so that's going to give us a lot more sophistication in the scripts that we can produce, so that we can do much more interesting things than just the kind of convenience things that we've done so far. But already, think about what the scripts that we've looked at already can do. We can perform calculations, we can output various things, we can take any command that we could type from the command line, we can put it into a script. And you can already imagine how useful it will be to be able to do this kind of thing, because if you find yourself doing the same sequence of things from the command line over and over and over again, then you say, hey, I could turn that into a script, and then with just one word, I can do that same thing over and over again, rather than having to type first the first command, then the second command, then the third command. So as we gain more capacity to do more and more interesting things, we'll be able to automate those, even with the simple tools that we have now. But fear not, your tools are going to get more sophisticated as we go. And we'll be able to do a great deal with even very short, simple scripts.